Welcome back to the deep dive. We're here to really get under the hood of the big ideas shaping our world. We live in a world that's increasingly run by machines, don't we? Think about it. Those agile robotic arms on a factory floor, or the huge, complex conveyor systems zipping packages around. We see these marvels of industrial automation everywhere. They're reshaping how we make things, how we move them, everything really. But have you ever stopped to wonder what the actual physical backbone of these systems is? What's holding it all together? There's this almost invisible foundation, a material that quietly underpins this whole tech revolution. A silent enabler, you might say. Today, we're diving deep into the, surprisingly fundamental world of aluminium machine section profiles.
That's exactly right. And these profiles, they aren't just bits of metal. They're more like the structural DNA at the very core of modern automation. Our mission today is to unpack not just what this seemingly simple material is, but why it's so strategically important and how it works its magic and where it's really shaking things up across industries. We'll explore its incredible versatility, its engineered strength, and the huge impact it has on manufacturing agility and, well, beyond. It's really a foundational piece that enables so much of what we think of as advanced today.
Okay, let's unpack that a bit. When you say aluminium machine section profiles, are we just talking about basic aluminium bars, or is there something more specific, some clever engineering going on here? What are they exactly?
Oh, much more than basic bars. Think of them as precisely engineered structural components. They're meticulously crafted through something called an extrusion process. Imagine squeezing toothpaste from a tube. It's a bit like that, but with heated aluminium being forced through a very precisely shaped die. This creates these continuous, often quite intricate profiles with specific cross-sections, designed specifically to support automation systems. And their core properties are really engineered for performance. You've got exceptional strength-to-weight ratio, which is crucial, really, for minimizing inertia in moving systems. Then there's inherent corrosion resistance. That dramatically cuts down maintenance, especially in tough industrial settings. And finally, unparalleled adaptability, thanks to those precise extruded shapes.
Okay, and you mentioned specific alloys.
Yes, exactly. We're generally talking high-quality aluminium alloys. Specifically, 6061 and 6063 are very common. These aren't random choices. These specific alloys, because of their magnesium and silicon content, they offer this optimal balance. Great strength, easy to machine, good weldability. So they're incredibly robust and versatile for complex industrial jobs, but without adding lots of weight. This combination, that's precisely why they've become the backbone. They literally form the frameworks for automated production lines.
Right.
They're the skeleton for sophisticated conveyor systems and the sturdy yet light support for precision robots.
Right, that detail on the properties really helps paint the picture. But let's zoom out a bit. How do these profiles, just by being what they are, actually enable those bigger strategic moves towards industrial automation? Not just supporting one machine, but the whole wave. What's the kind of ripple effect across, say, a whole smart manufacturing setup?
That's really the heart of it. It's not just about building one strong machine. It's about building an entire ecosystem that's flexible, efficient, and scalable, you see. By providing a standardized yet highly adaptable framework, these profiles massively lower the barrier to putting in new automation. Think about setting up a brand new smart factory or even just upgrading older systems. These profiles are vital. They support modular assembly systems, let companies build custom machine frameworks really quickly, and drive those automated conveyor systems that, link up different parts of a factory. Without this physical foundation, honestly, the rapid pace of automation development and rollout would be much, much slower. They're the quiet enablers behind faster production cycles, less manual work, and that whole push towards Industry 4.0.
Okay, so it sounds like these profiles aren't just a one-size-fits-all solution then. Given how adaptable you say they are, what kind of structural designs are we actually talking about? What are the different shapes that make them so versatile in the real world? How do they do so many different jobs?
You're spot on. They come in various forms, each one carefully tailored for specific industrial needs. It's like having a specialized toolkit. One of the most common, and maybe most versatile, are T-slots. You've probably seen them. They're famous for their modular design. It means you can easily assemble and, importantly, reconfigure machinery frames, enclosures, workstations, all without any welding.
No welding. Wow, that must save a lot of time and hassle.
Huge savings. You just bolt components into the slots. You can move them, add new ones, no specialized tools, no hot work permits needed. This makes them absolutely perfect for rapid prototyping or iterative design. You can literally adjust a layout overnight to test something new.
That's incredibly useful. What else is in the toolkit?
Well, then you have things like U-channels. They've got that characteristic open profile. These are great for support structures, really good for managing cables neatly, or for protective edging around machines. Also used for machinery alignment guides and safety covers. Their simple shape makes them versatile for those functional but not necessarily heavy load-bearing roles. Now, for the heavier stuff, when you're dealing with significant forces, you've got H-beams. These are designed specifically for heavy-duty framing and load-bearing systems. They offer much higher structural integrity. You'll find these where systems really need to take substantial mechanical stress, supporting heavy loads without bending or flexing too much.
And I guess beyond these standard shapes, industries must have really specific niche needs sometimes.
Absolutely. And that's where custom extrusions come in. Many manufacturers, like Eleanor Industries that we looked at in the sources, they specialize in delivering tailor-made profiles. These can be designed precisely to match a specific equipment or meet really unique design constraints. Maybe it's for a pharmaceutical packaging line needing specific dimensions for sterile conditions, or for custom robotic arms needing unique mounting points. This deep adaptability, the ability to basically create a profile for almost any design challenge, that's key to modern lean manufacturing and highly specialized automation.
Okay, this idea of modularity is really interesting. You mentioned bolt and slot designs. Can you walk us through how these systems, which sound almost deceptively simple, actually transform how agile a production line can be? What does that really mean for a company trying to quickly switch to a new product or maybe cut downtime during an upgrade?
Oh, it's a genuine game changer. I remember years ago working on a project with a rigid welded steel frame. Making even a minor adjustment, changing one step in the process, meant a full day of downtime, sometimes even longer. Cut, weld, repaint. With these bolt-and slot aluminum profiles, that same change might take minutes, maybe an hour max, not a whole day. This ease of assembly means you don't need complex welding skills or specialized technicians for every little tweak. Companies can assemble structures incredibly quickly, or, just as importantly, disassemble and reconfigure them as their production needs shift. You can span a line, shrink it, change it completely, all responding to market demand.
So it's about responsiveness, really.
Exactly. That responsiveness isn't just convenient. It fundamentally changes a company's strategic agility. Imagine a manufacturer who can retool an entire line for a new product variant in just days, not weeks. They can grab market share faster. Or they can prototype and iterate designs at a speed their competitors just can't match. And then you have toolless connectors that make some adjustments almost effortless. Click, twist, done. This feeds directly into lean manufacturing principles. Minimize waste by adapting instead of scrapping rigid setups. Respond to market shifts with incredible speed. It really transforms factory floors from static things into dynamic, living systems.
That really highlights the versatility. So the physical shapes allow this amazing adaptability. But let's dig into why that matters so much for a business, for their bottom line. What are the core advantages that really lift aluminum profiles beyond just being a basic building block? What makes them a strategic choice for automation and material handling?
Right, there are about 5 key advantages that really make them indispensable for modern industry. First, as we touched on, their lightweight but strong nature, that high strength-to-weight ratio. And it's not just about making things lighter, it actually impacts the performance of dynamic systems. Reducing equipment weight improves load-bearing efficiency, sure, but it also cuts down on inertial forces in moving parts. This means faster acceleration and deceleration, which is critical for the speed and precision needed in modern automation. It can even lead to lower energy use over time simply because you're moving less mass around.
Okay, that makes sense operationally. What about the financial side? It sounds like there could be big cost savings involved.
Definitely. Which brings us neatly to the second advantage, cost-effective manufacturing and installation. Compared to traditional materials like steel or maybe some composites, aluminum is just much easier to fabricate, cut, and assemble. This translates directly into lower labor costs during build, much faster installation times on the factory floor, and even less wear and tear on machining tools. But it's not just the upfront cost. Think about the total cost of ownership over the system's life. Lighter systems might use less energy when moving. Less corrosion means lower maintenance costs down the line, and that modularity. It drastically cuts the cost of future changes or upgrades. So it's an investment that keeps paying back across the whole operational lifecycle. Faster deployment, lower total cost.
And in today's world, sustainability is huge. I imagine that plays a role too.
It's absolutely paramount, and that's our third key advantage. They are recyclable and sustainable. Aluminum is 100% recyclable without losing its quality. You can melt it down and reuse it again and again. This makes these machine section profiles an inherently environmentally responsible choice. It fits perfectly with lean manufacturing goals and those green factory initiatives you hear about. It contributes to a circular economy, boosts the company's ESG environmental, social governance profile, and helps with long-term resource management.
Okay, so we've got strength, cost effectiveness, sustainability. What are the other two big benefits?
Fourth is that they are incredibly customizable to specific machinery needs. This flexibility is a massive plus for engineers. Whether you need specialized T-slots for mounting sensors just right, or unique modular connectors, or maybe reinforced joints for particular stress points, these profiles can be tailored for almost any unique machine design. This adaptability supports really specialized automation setups, custom robot arms, modular workstations. It lets engineers innovate and adapt really quickly to specific production problems, fosters rapid iteration.
Right. And finally, pulling all these advantages together, what's the ultimate impact on how a business runs, its performance?
Well, the fifth point is they profoundly enhance production speed and efficiency. By streamlining how you build machine frames, safety guards, enclosures, transport lines, and combining that with the modularity we discussed, industries can make quick adjustments, perform upgrades rapidly, or carry out maintenance much faster with less disruption to production. This ability to respond quickly to workflow changes or market demands gives a significant boost to overall productivity and throughput. What's really cool here is how these, seemingly simple components, through their smart engineering and flexibility, add up to such big strategic improvements for a whole company.
It's one thing to talk about properties and benefits in theory, but where can we actually see these profiles making a real difference? In industries that you or I interact with every day, where does this stuff come alive?
Oh, they're truly everywhere once you start looking. Quietly holding things together in a huge range of modern industries. Think about, say, automotive manufacturing. The pace of innovation there is relentless, isn't it? They're constantly retooling for new car models, and these profiles are the unsung heroes that allow that flexibility. They're used for the frameworks that hold car bodies during assembly, for automated material handling systems, for robotic arms, and critically, for safety enclosures around high-speed machines. Companies like Eleanor Industries, mentioned in our sources, are known for supplying the kind of precision-engineered profiles needed for the auto sector's tough demands for accuracy and durability.
Okay. And what about places where hygiene and precision are absolutely critical, like medical or food?
It's exactly. In the pharmaceutical and medical equipment world, their properties are vital. Cleanroom-friendly, non-corrosive, easy to sanitize. They form the precise framework for diagnostic machines, automated pill dispensers, sterile packaging lines. Anywhere, contamination or material breakdown would be a disaster. Those tailored solutions we mentioned, like Eleanor's, ensure they meet incredibly strict health and safety rules. And it's similar in food processing plants. Hygiene is number one. Aluminium profiles give you that rust-free, easy-to-clean structure for conveyor systems, sorting machines, robotic packing units. They stand up to frequent washing down and help prevent bacteria building up. Again, companies like Eleanor focus on meeting both the functional needs and the tough sanitation requirements in that sensitive industry.
So basically, anywhere you need precision, cleanliness, or the ability to change things fast, these profiles are likely involved. What about really high-speed stuff like packaging lines?
Absolutely crucial there. For packaging and robotics, you often have very high-speed lines and complex automation. Structural accuracy and modularity are essential. Aluminium profiles are used to build scalable frameworks, guide systems, precise mounts for sensors, everything needed for motion control and smart robotics. They allow quick changes for different packaging formats, too. And then there's electronics assembly lines. Think microchips, circuit boards. Here you need ultra-high precision and super clean environments. These profiles offer vibration-resistant, non-magnetic, and electrostatic-friendly structures, ideal for circuit board assembly machines, testing equipment, SMT surface mount technology machines, places where damping vibration and avoiding magnetic interference is critical for placing tiny components accurately.
Okay, this is incredibly insightful. Now, if someone listening today is thinking, maybe this is relevant for my operation, or they just want to understand the choices better, what are the really critical factors they need to weigh up when picking the right aluminium machine section profiles to make sure they get the performance they need?
That's a really important question. Making the right choice is key to getting the best performance and, frankly, the best return on investment. First and foremost, you absolutely have to consider load-bearing capacity. The profiles need to be specifically designed to handle the mechanical stresses they'll face in your specific automation system. Is it for a static frame? a dynamic gantry moving heavy parts, load-bearing structures in assembly lines or CNC machines. You need to think about not just the weight pressing down, but also twisting forces, vibration. There are specific high-strength profiles available, like those Eleanor Industries makes, engineered precisely for those heavy-duty needs.
Right, match the profile strength to the job. What else?
Second, evaluate the environmental exposure. Where is this system going to live? While aluminium naturally resists corrosion pretty well, some environments are tougher than others. Think really humid places, dusty factories, maybe areas with chemical exposure. Textile factories, for instance, benefit hugely from rust-free profiles because of the humidity. Chemical plants have their own challenges. You can get profiles with extra protection, like anodizing or powder coating. These significantly boost protection, extend the lifespan, and can even improve the look.
So it's not just the base material, but how it's finished for its specific environment. Makes sense.
That's exactly right. The third critical factor is compatibility with existing systems. Unless you're starting completely from scratch, the new profiles need to integrate smoothly with what you already have. That means connecting with existing brackets, fasteners, actuators, sensors, all those bits and pieces. Using standard sizes and modular designs, often available from a manufacturer's extensive die library like Eleanor's we noted, makes this much easier. It ensures a good fit, cuts down setup time. But if you have a really unique automation layout, custom profiles are readily available. They let you integrate perfectly without having to compromise your design.
Okay, load, environment, compatibility. Is there a final key point?
Yes, and it's a really vital one. Sourcing from trusted manufacturers. Choosing a reputable manufacturer is crucial. It ensures you get consistent quality, precise dimensions every time, and, importantly, access to technical support when you need it. Companies like Eleanor Industries with state-of-the-art extrusion facilities, they can offer quick turnaround times and, crucially, they adhere to strict international quality standards, right from the design phase through to delivery. It just gives you that peace of mind, knowing your automation's backbone is reliable, accurate, and built to last.
Wow, what an incredible journey we've taken today. From the basic definition and clever engineering right through to the surprising versatility and strategic impact of these aluminum machine section profiles. It's really clear they aren't just simple bits of metal, are they? They're critical enablers, the unseen architects working behind the scenes of our automated world. We've seen how their unique mix of strength, adaptability, and their sustainable nature empowers everything from those agile robots to precision medical gear.
It is fascinating, isn't it? How the silent structural parts often dictate the biggest, loudest innovations. And as automation keeps pushing forward, constantly advancing what's possible, just imagine how these versatile aluminum profiles will continue to evolve. They'll keep shaping the next generation of smart factories. They'll redefine medical devices, maybe even change how our food gets to us. They'll adapt to new challenges, new demands. And that raises a really interesting question, I think. What other everyday materials might be out there, quietly revolutionizing their own industries right now, just waiting for us to take a deeper look and really grasp their strategic significance?
That's a fantastic thought to leave things on. A great reminder for all of us to look a bit closer at the world around us. Thank you so much for joining us on this deep dive into the hidden heroes of industrial automation. We really hope you leave today with a bit of newfound curiosity, maybe an appreciation for the unseen forces shaping our modern world. Go forth and observe with fresh eyes.